Hello, nice to see you here today. Um, Let us introduce ourselves, who we are. My name is Vladimir Petriko. I'm developer in Fibery. I practice software engineering for almost 20 years. Also, I have additional education in machine learning. My graduation work was dedicated to generative text models. Before it was a hot topic as it is today. And this is Max.
Yeah, hello, thank you. My name is Max. It's a pleasure to be here. Recently, I finished master studies, mostly exploring intersection of fields of generative AI and unsupervised learning algorithms like clustering. And I'll be talking a bit later about theoretical foundations of our features and why we decided to do one way and not the other. So, Vova, stage is yours.
Let's start. Our today's talk is called When AI Meets Flexibility. And here is our plan for this talk. We plan to give you some intuition about what Fibery is. Also, then we'll follow 10 minutes demo where we will use AI to set up interactive game with you. After that, we will listen Max, who will make a technical deep dive into Fibery AI implementation. And also, in parallel, you can take your time to continue play the game. And after that, we plan to close the game and award the winner. And after that, we will have a small QA session. So let's get started. What is Fibery? Raise your hand who knows what is Fibery or maybe heard something of it. Quite a lot, to be honest. To continue, I have to give you some introduction. What is Fibery? Our marketing team states that Fibery is operating system for a company. Our user champions told us that we make a flexible constructor for business processes. Our engineering team inside thinks that we made yet another flexible no-code tool. But what everyone agrees on is that Fibery is something flexible. But what is flexibility? How can we define it? Basically, Fibery business is built on idea that most business cases for small to medium business can be expressed as an open set of objects with special properties, and we call that objects databases. Don't be scared, here's some examples. For example, Scrum process for software development can be expressed in terms of release, story, bug, and sprint. Sales CRM, sales process can be expressed like a CRM with following set of objects like account, activity, opportunity, contact. But what makes Fibery databases so special? Actually, it is a set of properties these databases own. Here. Logically, they can be split into three parts. First part is schema, which defines data structure. It includes relations and primitive fields for structured data and rich text fields for unstructured data. Also, I must say that relations is very powerful property in Fibery because it allows to scale system and adapt data domain to a growing user needs. Then formulas and rules are actually behavioral properties. They force data structure to follow some rules. And finally, permissions and views, which basically a visualization. And visualization defines a bunch of ways to represent and manipulate specific data from a database. Permissions actually also very powerful property, but it is out of scope for today's talk. What can be visualization? Visualization is a set of such views like table, board, list, timeline, calendar, very powerful reports and charts. Also feed, map, document, whiteboard, and form. Also, plus to that, you have a possibility to chat with your data with custom chatbots. Let's imagine a situation when we make this property set weaker by throwing away relations, rich text fields, permissions, and leaving for visualization only basic charts and powerful tables. What do you think it is? I think that this is known product. You know it as Excel. So basically, Fibery takes this idea to the next level by adding some new dimensions to this property set and enabling on this data structure through multi-user collaboration. Fibery is powerful enough to interconnect all information within an organization and replace or in some way integrate data from different tools companies usually use for tasks like CRM, sales, product management, HR, and things like that. Our sales portfolio includes schools and educational organizations, laundries, churches, libraries, and even cannabis farms. So Fibery basically is very powerful and very flexible. Now let me show you how AI is integrated into such flexible system from the product perspective. We will try to create a game inside Fibery using AI help along the way. So 10 minutes adventure, in and out. Okay, game is the best way to learn something new. So we have 2 prizes for you. First prize, prize A and prize B. Each of one is actually a very cool book you want to see. One is old school and then very practical one. And I propose you to play a game called Guess Half of the Average. Rules are the following. I challenge everyone to guess a number between 1 and 100, such that the number is as close as possible to half of the average of all players' guesses. So player who make a closest guess and do it first will win. So I challenge you to think about strategy, because you should consider not only own strategies, but also guesses of others. Okay, let's come to setup. So we have 2 databases here, game database and the price database. What is missing here is a player database. We can make it manually, but let's challenge AI to do that for us. So let's do some prompt engineering. So we ask AI that we need players database. Then we state that player should be identified by email. Then we state that player's guess should be a number. And let's allow player to leave feedback. Then let's define that player participate in one game once. And player can win 1 prize only. Let's generate. So what is proposed changes? Create new database with fields and some relations, many to one and one to one. Let's apply changes and see what's happening. So we see that player database is created. Okay. So we see a set of fields we asked to create: guest, feedback, email, and a pair of relations: relation to game, one-to-many, and relation to price, one-to-one. Let's go and add one player manually. Let's identify it by email. For example, test at Fibery.io. And fill in some fields, like make some basic guess, fill in our game, and let's leave property price empty for a while. Then to enable everyone to play, we need special type of view called form, which actually represents our database. So we don't need price here, and let's reorder it a little bit and go through fields. So email field should be required. Guess field also required. Let's make feedback optional. And the game property, let's make it hidden, but set up default value to our game. Then let's change response and wish a good luck. And of course, let's change a cover. Doing some repositioning. Cool. Let's create our first player via this form. So I enter my email, vova@fibery.io. I made some basic guess and leave some feedback. What a boring talk. Do you agree? Submit. So we see a new record which represents all our data we just entered. So we see that we have two guesses here, and average of these guesses is 50. But outcome of our game should be half of the average. So let's go and add a formula to a game database. Call it outcome, and ask AI to generate formula for us by the following prompt: half of the average of all players' guesses. It looks correct. So we see that outcome of 50 is 25, which seems correct. Okay, let's do another measure from the player perspective by adding new formula which define deviation of user guess, player guess. Let it be a square difference between user guess and game outcome. We use squared because it creates always positive value and greatly emphasize errors. So let's make it clear. So we display guess and display deviation here, and make some reordering. So now let's go and create another player who made another guess less than 50, for example 25. and leave some feedback. Okay. So we see this record here, and we see that average of guesses has changed, and game outcome has changed also, and it becomes slower. So now let's go and add some behavior to our player database. And we need some protection, so let's kick cheaters off. This rule should be triggered on player created or player updated when email or guess properties are affected. And let's do it via script and ask AI to generate it for us. So here we describe our needs. Kick from the game players with duplicate email or guess, which is out of 100 range. So we got some results, and you see, just imagine you have to enter it manually. So you see, let's test our automation. You see, I made a mistake here, and if I remove this redundant dot, I will have a duplicated email, and this record should be kicked from the game, and it works. Let's test another rule and test guess more than 100. Kick it from the game. And another test for value less than 1. Kick it from the game. Cool. Let's get back this player to game because it has valid guess. And do something interesting. We go to our space and ask AI to create a view which show players out of any game. So we see it created a view for us, two familiar records, and this view is created using a filter. And if we disable this filter, we see all our records we have in our database. So let's back it, enable. And what is left is to make our form public. Let's share it to the web. Okay, and let the game begin. So you can start scan this URL, but also this QR code will be available during the following talk. And now let me invite Maxim.
Thank you. So, as I said, I'll delve deeper into theoretical parts of it. And now, as you saw a decent part of our AI capabilities in action, let's see how things work inside, starting from Fibery working components and how we can represent them. And it can mostly be done by either using text or bare JSON for unstructured or structured data. And both of these things can be easily generated using AI. So that's what we did. We essentially applied it for every component you can see here. And we used a common technique for this, as you may guess, which is called prompt engineering. Now, of course, prompts will look different depending on what kind of task you want to perform, whether you want to generate some text for rich text fields, or create relations and primitive fields, write better formulas, or create views. However, underlying implementation remains roughly the same. So I would like to take formulas as an example and show how we've implemented AI there. And a quick look onto formula UI creation. So here I ask our formulas AI to generate total spendings of a customer. So on the right side of the slide, you can see we have database customer with one-to-many relation to database order. And so essentially, I want to sum up prices of all the orders. And now from the point of view of the model, what it should get to be able to generate such a formula. It should get, of course, the name and description of my request, so what kind of formula I like. It should also get, in case of Fibery, related schema to my request. So what fields it can use in its answer, and what kind of relations it can use as well. And it will also get how to use our formula syntax. So we will provide AI rules it can apply. But coming up with such a formula first time is kind of hard for any model right now. And it's very common to give it some examples before actually asking a real request. And so for this, we have two common methods. The first one is called in-context learning. It is a fancy way of calling just giving a bunch of examples to the model. So as you can see here, I give it 2 examples and then asking a real request, hoping the model will get the pattern that is present in my examples and will use it for the final response. The second approach is to take pre-trained model and fine-tune it based on your data. So you collect these examples into a file and tailor the model to your needs. The main advantage of such approach is that then you don't have to use examples during inference. So the model already knows what it's supposed to do. And of course, it's a bit cheaper during inference time. However, performance of the two methods, in other words, quality of response of the model, remained roughly the same. So we decided to go for the first approach, which is in-context learning. And also, secondly, because we decided to generate examples dynamically based on incoming user schema. But I'll talk about it in a bit, because first, we thought we can get away with predefined set of examples. And particularly, we put them all into a single message and sent it to the model as it is, hoping it will understand what we mean. Turns out not to be the case. It doesn't really understand what it's supposed to do. So then we decided to split each example into a pair, where the first message is user request, and the second one is assistant's response. And a quick reminder here, user requests contains formula name description and related schema. And so when we move on to examples themselves and how we've generated them, essentially we created 3 different domains in Fibery: DIY, local shop, and project management, to try to broaden model's view in examples on what kind of data it can face. And we created formulas ourselves, written some descriptions, and put them in as an examples to any user request that was coming in. We started to see problems with such approach right away. And the main one was that the model would take fields and relations from example schemas in its final response and not from the user schema itself. So we thought we can get away with simply adding more examples. And so we kept testing our current set and adding more examples where the model failed. And we kept testing and adding more examples. And the sets basically started to inflate. And at some point, we end up with something like this. So yeah, we had to change something. And what we decided to do is to get rid completely of predefined set of examples and instead generate them dynamically based on incoming user schema. So how it works? We have the user schema in the request, which already contains fields and relations the model can use. And somewhere, we also store a list of example templates, which are relevant for different field types. And so each template here already has formula name, description, the formula itself. However, it does not have a field name yet. And this is a job of fitting function to take an example template, take a look at the user schema, and try to find fitting field. And if it finds one, it generates us an example. And so this approach, the main benefit of such approach is that we do not have to use any predefined schemas in examples that model always hallucinates about, and instead we focus only on user schema. Of course, it takes a bit longer, but it's still fine. And we saw a huge performance boost using this approach, because now the model has nothing to hallucinate about. And that was prompt engineering in Fibery, and it is applied to every component you can see here. And while this technique is great for generating content, we needed a different AI technique to help user to find relevant information more easily. And that's where embeddings come in, and we use them for search and clustering in Fibery. So what are embeddings in the first place? Essentially, you have some text, and when you feed it through the large language model, you get an embedding. So from this diagram, you can think of embeddings as of vectors that try to represent semantic meaning behind the text. And that's very important because they do not simply encode the words they see, they try to look deeper into the meaning of the sentence you gave it. And if you do such thing many, many times, you end up with a vector space, or in this case, embedding vector space. And each point on this drawing here is a vector. And this space has a very nice property to it. And it goes as texts with similar meaning will end up close to each other. So if you try to embed dog and cat, they're both domesticated pets, they will be somewhere close. And texts that have completely different meanings will be far away. And this property is very important because now we can use this embedding space to search it. And although, a fun fact, we can perform mathematical operations on embeddings and get actually quite meaningful results. So if you take vector of France, so you embedded word France, and subtract vector of Paris from it, essentially you get like country without a capital. And then if you add Madrid to this country, you will land somewhere close to Spain in the embedding space. And so that's kind of fascinating to think about. And at the same time, this exact property of embeddings, ability to represent semantic meaning mathematically, is what makes them so powerful. And now, when we know the concept of embedding, we can move on to implementation and how we've done it in Fibery. And in our case, texts are written by the user himself. So suppose we have a database of tasks. Each task has name and description. And so this would be the text that we embed in Fibery. And before embedding, we will split each document, so each task, into smaller chunks. And this is very common in the field, and it is done in order to not to mix a lot of concepts in a single embedding. Because suppose you have problem written out in the task, solution to it, maybe some comments, etc. You don't want to mix it up. Embedding becomes too generic, and it contains too much meaning. So we split it into multiple chunks and embed them separately. And so that's the next step. We embed them. In our case, we use OpenAI. However, we already think in using something else, and store them in a table. And then, in order to make embeddings useful, in other words, search them, we have to also upload them to a vector database, because relational databases are not really fit for vector search. So that's the last step of our diagram. And I would like to delve a bit deeper into splitting and loading steps now, because for splitting, we decided to use 3 different strategies. The main reasoning behind it is that we wanted to capture context on different scales. So the first one is large, and we split text into huge chunks, 2,000 characters each. The second one is looking at the headings of the document and splits based on them. And these two will be applied to any text you upload to our vector database. And third is called paragraph, and it splits text into chunks of couple of paragraphs, which each chunk contains a couple of paragraphs. And this one we use mostly for clustering, which I will be talking about in a second. And now when the whole text is split and embedded, we can upload it to vector database. In our case, it is Pinecone, and we've chosen it mainly for 3 reasons. The first one, it was very simple to set up because it's completely cloud. Secondly, it implements serverless architecture, which is, in other words, pay as you go, and you don't have to pay for resources you do not use, which saves us a little bit of cost. And thirdly, it allowed us to define metadata fields on embedding level. So if we already know what kind of embeddings we are looking for example, a certain type, we can narrow down the search right away. And that's the feature that not a lot of vector databases provided at the moment. So that's why mainly we decided to go for Pinecone. But all of these things, splitting text, embedding it, uploading to vector database, is done in order to improve user search experience. And so that's what happens when a real user query comes in. Maybe we are trying to look for some task. The first thing that happens in Fibery is we go to a keyword search engine. In our case, it is Elasticsearch, and under the hood it uses BM25. And that's like standard search that is present everywhere. Secondly, though, in parallel, we also go to semantic search. And so we embed user query first in order to obtain a vector, and then we query a vector database. And when both of these systems return some results, we mix them up. And we use a simplistic algorithm which is called reciprocal rank fusion, which is essentially an algorithm which is specifically designed for mixing results from multiple search systems. So that's how searching is implemented in Fibery. However, we realized that we can take it even further and use embeddings for clustering. And so what clustering means is grouping closely related text chunks, or embeddings in our case, together, which form a cluster. And a perfect use case for this is feedback. So suppose you have some feedback about your product, and you want to reveal most commonly requested features or some patterns that present in this data. And so clustering would be a great fit. And in our case, how it was implemented theoretically. We get an embedding table, which, as you remember, each entry here is simply some text chunk. And ideally, we would like to just apply clustering algorithm, maybe a bit more sophisticated one, like HDB scan, and get some clusters right away. However, we figured out that this approach is too generic. And by too generic, I mean that we would get just a couple of clusters. They would be huge clusters, but they contain only like positive and negative feedback. So we had to encourage the pipeline to provide us a more specific clusters. And the first thing that we decided to do is get rid of irrelevant information. So in our case, definition of irrelevant would be text chunks. They don't carry any particular opinion about something. So reviews like I love Fibery would be filtered out. Although they are nice, they are not really specific. And reviews like your tables are fast are pretty good for clustering. And this is done via customly fine-tuned large language model. And during fine-tuning process, we figured out that we can categorize each embedding into one of the two categories. The first one is problems, and the second one is insights. The main reasoning behind this is to encourage clusters to be even more specific. So now we form clusters of problems and of insights. And extremely common step in the field of unsupervised learning and clustering in particular is to apply dimensionality reduction to embeddings. In other words, you try to shrink number of dimensions from a couple of thousands that usually embeddings have to just maybe 50 or 100. And although it was written in every literature that this step has to be applied because density-based algorithms don't really love high dimensions, and this is called cursive dimensionality, we found out that it gave us two generic clusters again. So all of this work that we've done to make clusters more specific was simply thrown out. So we decided against using it, and instead simply cluster problems and insights separately right away without applying any dimensionality reduction. And from practical point of view, how it was implemented, into words, we had three services. The main one is orchestrator, and two dedicated ones, classification and clustering. And the first one would accept the job request, start to pre-process the data. In our case, we removed punctuation, links, emails, all the stuff that is not needed for classification service. And then we wait until we classify each embedding into problem, insight, or none. So we filter it out. And a quick side note about classification service. As you remember, we fine-tuned a custom large language model, and we had to host it somewhere. And we decided to use RunPod for this, which is essentially a GPU cloud. And we chose this company specifically because they offered scale to zero feature, which shut down your GPU server when there are no requests for maybe 10 minutes. You can set this time on your own. And then it starts very quickly on the first request. And of course, when the server is down, you don't have to pay anything. And that saves us a lot of costs on hosting GPU, because unfortunately, there are not that many clustering requests yet. And once embeddings are classified, we can start cluster them. And here we also apply a little trick. We run multiple clusterings with different set of hyperparameters. And so set of hyperparameters basically controls how clusters form. And they can be set of these hyperparameters can be optimal for different kinds of data. So you have to cluster it many times in order to get the most optimal ones. And when we find these, and this algorithm is automated, we return the most optimal clusters back to orchestrator. Then we name each of these using GPT and basing on text chunks that got into the cluster. And then we create everything in Fibery for users to take a look at these. So entities, highlights, views, whatever is needed. But I think it was too much, and now it's time to go back to the demo. And let me show you very quickly how clustering is performed in Fibery. So here, let me go first to the setup. We collected approximately 3,000 reviews from Google Play about Twitter, now called X, and we would like to get some topics out of it. So we can cluster it, select review topic, and start. We can also select a date here. However, clustering usually takes from 10 to 20 minutes to complete, so I ran it before the presentation. And once it's done, you will get notification in your inbox, and if you click on it, you can see a table where each row is a topic that our algorithm was able to find. It already has some sentiment to it. And here you can see how many related fragments it has. And so the way to explore it is simply to click on it and see what users think about Twitter nowadays. Seems like they're not really happy. And so this way of viewing information is much more structured than just to go from feedback node to feedback node one by one. And on this, I would like to finish my talk and give a word to Vova, who will hopefully show you results of the game. Thank you.
I hope you enjoyed. Okay, let's first of all, let's close our game. So you have a last chance to make your guess. Everyone? Okay, let's. Okay. Where is it? Let's give people maybe from online also to make their guess. So we don't know what will be the outcome. All this happen live. 5, 4, 3, 2, 1. No more bets. Okay, let's close our form. Stop sharing. No more bets. And before we look on our winner, let's make one more thing. Let's see if AI is good enough to play this game too. I saw that some of you all tried ChatGPT to make their guesses. But let's ask Fibery AI to do that for us. Let's go to our game and ask AI to make his guess. By the way, you have ability to create your own prompts and save them in Fibery. So this is quite interesting feature. Maybe you missed. Oh. Okay, I have to relog in. Sorry, guys. Because, no, just a second. So you can not only create your own prompts, but share it with a team. Here is it. We ask AI to make his guess. I made the prompt, special prompt, which explains how to play this game, and also ask AI to make his guess. So the idea is that if, for example, everyone in this audience make a guess 50, then half of the 50 will be 25. And if you are smart enough, you will think, okay, let's my guess be 25 better. So if everyone also smart enough, they also make a bet 25. And this, using this iterative strategy, you should come up to so-called Nash equilibrium, where the best guess should be minimal value available, which is in our case is 1. But this happens only if everyone in this audience is rational enough. So when you play, you should consider irrationality of your neighbors. So this game also used as a measure for community intelligence. So let's see, AI made a guess 13, and let's register it also. AI at Fibery.io. Okay. And before we proceed, let's see if we have some cheaters here. Yes, and we have a little bit. So guys, I warned you, this is Sparta. Let's see at distribution of all guesses. Distribution of our game. So let's update it. We see that average is almost 20, and half of the average is 10.41. And we have quite a lot of people here who was nearby. Let's go, and as I told you, we have a feature in Fibery, you can talk with your data. So let's go and ask AI assistant to show us top 10 players whose guess guess has minimal deviation. Let's see if it works. So we have some winners. Let's create a more comfortable view for this. And we see top 10 people who made a guess with minimal deviation, and minimal deviation is 0.2, and this is Kisel Nikolai. Is it here? So we give you a prize, and we send you an email using this button. You can then go and choose which book do you want, because one of them is really hard to read. So basically, this is it, guys. I hope you enjoyed this talk. Sorry? And second book will be for best question from the audience. So let's make some Q&A session now.
So, who's got a question? Please raise your hands. We need to make a mic. Yep.
Hi, I have a question about your custom fine-tuned LLM.
Yep.
Had you tried fine-tuning OpenAI models for this task?
Which task do you refer to exactly? Because
exactly
we tried. Prompt engineering one?
The clustering stuff.
Sorry?
Clustering stuff.
Oh, no, because it's too costful. It's much cheaper to just fine-tune it from Hugging Face, open source. And although, because we had to have a predefined set of labels, so what I did, I took LLM and put a classification head on top of it. So basically a feed-forward neural network and fine-tune it as it is. So
thank you.
Yeah.
Thank you for the demo. Maybe stupid question. Did you consider to buy some GPUs and just put it to your rack and by this just save cloud costs?
To our private servers, you mean?
Yeah.
For all the other stuff, we used Kubernetes, and we calculated that it will be more costful to host on Kubernetes. So we are looking for another provider.
Hold on.
Yeah, hi. So basically, you ask model to generate some code, yeah? Like code for your platform, for the constraints and so on.
Yeah. Essentially, it generates JSONs.
Okay. So how do you validate that this code it will actually work? So basically,
we try to run it.
So
we apply it first, like in demo, you can say way. If it succeeds, we present it to the user, and if user approves this, we apply these changes like hard.
And if it's not working?
You will get an error. That our AI is not smart enough.
Okay, so you do not regenerate it, no?
We tried a couple of times, because models can hallucinate and all of this stuff. We tried a couple of times, and we have a hyperparameter. And I think now we try 3 or 5 times, and then we simply throw an error.
Okay, thank you.
Yeah.
One of your slides showed the clustering.
Pipeline.
Yes, and one of the results was, you try different clustering algorithm, and even though you try to make it more specific, it still returned very generic clustering. Why do you think that is? Because you would naturally think that you, given it better classification, you would produce better clustering.
Yeah, sure. So the thing is that this is not clustering algorithm yet, and this is a step before clustering, where we try to shrink vectors. And in case of, it works for almost any data. But in case of embeddings, they are already so densely packed with information that we cannot reduce it any further. And if you remove half of dimensions out of it, it will try to, keep the meaning, but it will be too blurred. And so they become too generic again, and then clustering algorithm itself doesn't really know what embedding referred to in the first place. And so that's why it doesn't work. And that was kind of fascinating. I was sitting for 2 weeks trying to make it work, because it was written everywhere that it should work, and it wasn't. So I was pretty excited when I found it.
You saved somebody a lot of time.
Hopefully, that's what this conference is for.
If you're attentive enough, OpenAI in their documentation, they write explicitly that you don't try to make dimensionality reduction.
Yeah.
I have a question about data safety. Seems like you run your AI model on the entire user space, and there can be sensitive company data, and then you just send it to OpenAI, and then you send it to Pinecone and store there. are there any security consideration that you did, or maybe user can disable that if he thinks that he doesn't trust these companies?
Yeah, for sure. Vector search is not enabled by default in Fibery. You have to enable it and actually by hand add data you want to use. So that's like the first security measure, if you can call it. But then we also, for example, for Pinecone, we store all the data in EU. So we are compliant with GDPR. For OpenAI, right now we use it, but as I mentioned, by the way, we tried now to host embedding model in-house, not using OpenAI, exactly because of the concern you mentioned, the data leakage and so on. So yeah, we are working on it actively.
Thank you for the talk. I have one question also about data privacy. How do you separate your clients? I mean, do you have separate models for the clients? And if you don't, how you manage this? I mean,
so, sorry, I couldn't hear
the question
clearly. Yeah, sorry.
Yeah, I suppose that you have separate clients, right?
Yeah.
And their data should be separated.
Yeah.
And I would like to know how you manage this. Do you have separate models, separate prompting, or separate databases, or you have some different ways?
Yeah, and the question refers to clustering, as I understand, right? So, or to overall, like how we manage it. Sorry, but it's
mainly
specific.
About database, but also
yeah, sure.
on the clustering level, if you have something.
Yeah, on database level, we utilize Pinecone, and it allows us to split database on namespaces. So we just assign namespace per account in Fibery, and this way we split the data up.
And what about scalability then?
That exactly what serverless is for, because serverless allows you to scale very quickly. They charge you exactly in a pay as you go. So if we use, I don't know, 10 gigabytes to store data, they will charge us for 10. But they are ready anytime to provide us 100 or 1,000. Hopefully they will.
Okay, thanks.
Guys, we got a time just for the last question. We're gonna have a break afterwards. Please approach speakers, but for now, the last question.
My question is about that curious fact about vector substitution. You mentioned that if we subtract Paris from France and then add Madrid, we'll get Spain. Does this work with numbers, with words representing numbers?
Oh, that's a really good question. I have no idea. No, really, but I have to test this one out. Thank you. I suppose it... No, I think it shouldn't be like this. Because numbers, well, how you would represent in embeddings the difference between 7 and a 5, right? I presume they would be just all over the place.
I think it shouldn't be like this because then numbers become closer to other words than to other numbers.
Oh, yeah.
Right?
Yeah.
Thank you.
Thank you.
Guys, we need to wrap up. Thank you so much for the talk.
Thank you.
Whose questions you love most? Because you have at least 3 invitations to the after party.
Oh, we have to decide it now.
Well, you can, guys who ask the question, you can approach and fight, but you can...
I know, because we have to give a book to the best question in the audience.
Yep. Okay.
It may seem biased, but the last question was awesome. So I would like to give this question. So if you can come to the stage and later.